Hello, Year 12, and welcome to the 7th and last video here for this topic on the normal distribution. We're comparing datasets here using plots, back-to-back stem and leaf plots, and box plots, or box and whisker plots if you like. Rightio. For comparing two datasets, we're going to sort of try to put them on the same axis or something like that. Now, here we have a stem and leaf plot, a back-to-back stem and leaf plot, where in this center column, this is the first digit of our number. So this here represents the number 12, 1, 2. So 11 and 12. 11, 12, 13, 18 and 19, right, for the girls. 11 and 12 for the boys. 11, 12, 13, 18, 19 for the girls, and so on. The biggest score there for the girls is 49, and for the boys is 46. We can see a bit of a pattern here, right? I don't think that I want to say that it's skewed. I'm not sure that I want to say that, but we're going to have to. Part T. What is the modal amount spent for the whole group? Mode being the most common score. So, see, I've got 3 46s. Is that going to be it? I don't know. This is not a particularly efficient way of going about things here. 8 6s. I have 3 34s and 3 46s. I don't think I've got 4 of anything. So my modal amount is 30. Oops, what's going on there? 34 and 46. Yep, there's more than one correct answer. Oh, there's more than one mode. Right. What is the mean amount to the nearest dollar spent by the boys, the girls, and the whole group? Right. To do this, I'm going to have to drag out the calculator. So, here's the calculator. Clear it, turn it on. Make sure we reset everything. Second function 93 equals AC. Mode 2. And, look, you know what? For a data set like this, no, let's just stick with the one. Let's not complicate things too much. So I've got to put in 11, 12, and so on. So here are my 18 scores. You can see I've put that in. I press AC. Second function 1, 4, and 2 will give me the mean. Righto, a mean of 34. Oops. Now, I can put in the data for the girls and the whole group, or I can just sort of type them in, I suppose. It's pretty slow and painful. You get the idea. We've practiced those enough. If you need a hand, ask me in class. Compare the shapes. Well, I guess we're likely to say that boys we would say that is negatively skewed. And for the girls, positively skewed, right? Because there are more scores on the positive side of the median, of the mode for the girls, right? The mode, where it's the most, right? Now I sort of say the mode here as in, if we grouped it by tens, right? There's a lot of scores in the 20s. Actually, yeah, anyhow, positively skewed. Righto, it really does depend how we split up the data here, and I don't love these things, but anyway. And on average, who spent more? Look, I think at a glance we'll be able to say, oh, sorry, we forgot to do the range here. So the boys' range is from 11 to 46, which is a range of 35. The girls from 11 to 49. So the girls have a greater range. Right, girls have the greater range. I should say what that is. 49 minus 11 is 38. Right. Who spent more? The boys will spend more. It's going to be from part B. Because really, that's what we're talking about, is who spent more on average. C part B, but I didn't work out all the answers. But it is going to be B. If you feel like the practice for that, certainly punch the numbers into your calculator, confirm that that's what happens. Let's move on, though, to box plots here, sometimes called box and whisker plots. What we do is we draw up, or we indicate the 5-number summary. That's the minimum, the first quartile, the median, the third quartile, and the maximum. We put those 5 things above a scale, above a nice regular scale, and we join the 3 middle figures up into a box, and we sort of attach the outside 2 figures with the whiskers. Right, one above the other can be a nice way to fairly quickly compare 2 different data sets. So we can do this again on our calculator. I'm going to get it started. Second function 9, 3 equals AC, and do one of these by the magic of video sort of thing. So mode 2 for stat, sorry. Option 1, we've got this here, and I'll put my 24, 25, so on. Here's the data for Liz. It's all in there, AC. Now, second function 1, 5 is going to have all the things I want here. So 1, equals 24. So I'm just going to put over the side here. I'm going to go, 24, back to my calculator. Second function 1, second function 1, 5. The next thing that I want is 3, the first quartile, 25, 26 and a half. Then second function 1, 5, and I want the median now is 4, 29 and a half. Right, 2 more figures to get there. Now I'm going to erase all that data and do the same thing for George. So let's reset that. Second function, 9, 3 equals AC. Okay, and here we go. We've reset that and we've put in the data for George, AC, and I get those things out again like that. Here we go. We've used the calculator there to do this. I suppose for this particular question, because our data is already organised in ascending order, we could have done it without that. I could go, right, let's split this up into groups like this. And I want the halfway marks. So obviously my minimum here is 24, that's fine. My maximum is 35. Halfway between 26 and 27 is 26 and a half. Halfway between 28 and 31 is 29 and a half. 32 here. Here, halfway between 21 and 24, 22 and a half. 30 is halfway between here, and 35 is halfway between these numbers. That would be fine, but I did want to show you how to do that with the calculator. Get in the habit of doing it. If you have unsorted data that's not in ascending order, it's quite a lot of work getting that right. Anyway, so we've got these things. We need to, there's my 5-number summary, and I want to draw the 2 box plots on the same axis. So what I need is an axis that goes from 15 is my absolute minimum to 45. Right, so I'm going to do this. Whoa, that's pretty messy. Anyhow, that's going to be 15. That's 45. Right, so I'm going to have, what am I going to do here? I think if I have 30, we'll be halfway in between. Right, there's my 30 mark. Now I'll split that up like this. 20, 25. Now you should certainly use a ruler to do this and a pencil. 40. Okay, that's, kind of what it needs to be. Now for Liz, we do this. I put in a mark at 24, which is here. 24, 26 and a half. It's about here. Again, using a ruler. 29 and a half is about here. 32, about here. And 35. Right, so this is Liz. We join up the middle 3 like this, and the outside ones like that, and I should put Liz here. Then we do the same thing for George, here at 15, at 22.5. Where is that? Down here. Then 30, 35, and 45. So, the spread of George's data is significantly more. That's the main observation I would make from this, I think. Now, what are the interquartile ranges for each person? The interquartile range is the length of the box, size of the box there. So, for Liz, the IQR is, right, 32, 26.5 is 5.5. Oops, not there. 5.5. That's for Liz. For George, the interquartile range is now 22.5 to 35 is 12.5. Rightio. What is the median number of pamphlets delivered by each person? Well, that's where the stroke in the middle is. So Liz, 29.5. George, 30. Right, that's where that middle line there is. Compare the two data sets describing their shapes and measures of central tendency and spread. Look, I could say that George has a higher median than Liz, but I think it's fair to say that the medians are similar, right? The medians are similar. Both are approximately symmetrical. Okay, not perfectly, but approximately. And again, I think it's fairer to say that you wouldn't say these are skewed one way or the other. So there's the shape is symmetrical. The measures of central tendency, well, I would say the medians are similar, and for that matter, the means are likely to be as well. Is there a mode here? I've got a mode of 32 for Liz. George, mode of 38, but not very meaningful, I think. So I think that's okay. We've got a measure of central tendency. And spread, George's spread is much greater. Oops. Greater. And I'll give a couple of numbers to go with this. The range is 30. The interquartile range we worked out was 12.5. For George, and for Liz, the range is 11. And my interquartile range was 5.5. Pretty scruffy work here, Snell, but anyway. Rightio. So there's a fair bit of comparison going on there. Rightio. Make sure when you look at these questions, you read it very carefully. It says shape, central tendency, and spread. That's likely to be a 3-mark question. If you give all sorts of discussion about the spread, but you don't describe the shape, you're not going to get the marks, right? You can see that's what they're going to do there. Is Liz a better worker than George? Give reasons for your answer. Whew, hard to say, right? The number of pamphlets they deliver, sort of long-term average, is pretty similar. Liz is more consistent, I think we could say. Liz is more consistent. And maybe that's a good thing. Maybe it's not. And with a similar... Oops. a similar productivity. So probably better. Rightio. Oh, look, hilarious. Okay, that is it, right? That is it for the normal distribution. If any of that does make sense, that's certainly possible. But try to remember what that is and hit me up in class, ask me, and I'll give you the best explanation I can. Rightio, thanks guys. See you then.